Welcome back. Welcome back at this point. So here, beta. Yesterday I taught you fluid dynamics, like what is the Bernoulli's equation? P plus half of rho gh. Student, P plus half of rho gh. Right now, uh, plus beta what half of rho v square. Right, P plus rho g plus half of rho v square beta. Okay. So beta ji, for this condition, have a look everyone. Okay. Hare Krishna Adi beta. I'm very happy to see my dear. Okay, fine. So beta, we'll go through beta question here. Already, if you joined beta Advik here, so I'll not wait for any another candidate. If Advik is here, so I have to do questions only beta. Beta, put the heading beta ji. IIT Advance, beta Advance 1994. Students, Advance bacha ji, it's beta questions which came in IIT Advance 1994. Beta 2 marks. Students, 2 marks. Okay. So what's the question here? Just note down with the first here. A horizontal surface, beta ji, a horizontal, my bad, pipeline. A horizontal pipeline carries, a horizontal pipeline carries water, carries water in streamline flow. Beta ji, streamline flow. Student, streamline flow, full stop, at a point, at a point along the pipe where the cross-sectional area where the cross-sectional area is 10 centimeters square, comma, the water the water velocity the water velocity 1 meter per second, and the the pressure is 2000 pascal. The pressure of water at another point another point where the cross sectional area is 5 centimeters square is beta, you have to find pressure in pascal. Student, you can take density of water 10 to the power 3 kilogram per meter cube. 10 to the power 3 kilogram. Hare Krishna beta SR01. Hare Krishna, Jai Sri Shama student. Beta Hare Krishna, Hare Krishna student, Hare Krishna student. Okay, fine, let's say party. Just move everyone here further. So now everyone here, uh, beta, we'll go through this questions, beta. It's literally a good questions, beta. Today, beta, study I taught, beta, entire, I can say concept. Beta, in today class, I'll discuss, beta, only numerical here. Yes. Yes, beta. Today, beta, just beta tomorrow, beta, as usual, I'll do problem on viscosity. Sir, what are you do? Question, beta, simple, yaar. I wrote the question. Yesterday, I taught you concept, beta, ji. Right. Okay. So attention, everyone, here, beta. Okay. So students, what is the things here which you can use? No, everywhere, beta. At Steve, for this one, BK sir always following with a step-by-step solution of any questions. So have a look once here. A horizontal pipeline carries water streamline flow at a point along the pipe where the cross-sectional area, but I can say what initial here. You can take with a consideration like this for non-uniform cross-section. Beta ji, you can take here for non-uniform cross-section like this. Okay. So beta this area, let us suppose I'm calling beta G A1. This is beta G A2. A1 mention bacha. How much? My dear, 10 centimeter square. Okay. The velocity, okay. So beta velocity also mention bacha. How much? Beta G inlet, you can take beta inlet velocity, my dear. Uh, beta G, this is my dear 1 meter per second. Pressure, which I also mentioned, my dear. It's easy question here, not tough. Pressure inlet, which P1 also mentioned. Beta, how much? 2000 Pascal. Beta, how much? Pressure, which party? 2000 Pascal. Okay. So, yeah, we have A1, V1. We have A1, V1. Okay. So, yes. Outlet area also mentioned. Very good. The pressure of the water at another. Okay, another means, but I can say P2. P2, beta, there is what? A2 is mentioned here. It's a pretty easy question, bacha. Beta, how much? 5 centimeter square. What, my dear? 5 centimeter square. Everyone, come to the point here. So, beta, according to equation of continuity, bacha, according to yesterday I taught everyone, equation of, according to equation of continuity, equation of beta continuity, what we can use with the principle. Yesterday I said a1 b1 is equals to a2 b2. A1 bacha, no need to convert here. A1 b1, a2 b2, a1 and a2, because both are in centimeter square, so cancel each other, my dear. So A1 bacha part is very good, beta, my dear Atharva. Beta V1 bacha how much mentioned? This is 1. A2 beta ji how much? This is 5. Beta V2 here. V2 beta simply will get how much bacha ji? This is V2 is equals to beta. What, my dear? V2 is equals to 2 meter per second. Okay, if all I can say, if all of you got a same answer, so just show your reaction, everyone. V2 beta 2 meter per second. Okay, fine. Beta, we wish to find beta here. What is the pressure? So beta, we can use here what? Now beta, I can say step one finish, my dear students. Here in step two, beta, using Bernoulli's equation. Using beta the Bernoulli's equation. So what's the party? You can say P1 plus half. Beta, no pressure heat remains same, bacha. So no need to write bacha party. H bacha V1 square plus, let us suppose you can say rho GH is equals to beta. This is half of rho V2 square plus P2 plus बच्चा जी rho GS2. You can say H1 बच्चा party, but this is remains common बच्चा, so you can cancel each other. Beta, what you can say cancel each other बच्चा. So finally beta P1 plus half rho V1 square is equals to P2 plus half rho बच्चा V2 square. We wish to find P2 here. So P1 beta how much mentioned? 2000 Pascal. 2000 beta half beta density of water we can take beta 10 to the power 3. V1 beta 1 beta. So this is no need to worry. This is remains one only. Is equals to P2 beta plus 1 by 2 beta. This is you can say 10 to the power 3 and V2 beta we got 2 here. So you can say 2 to the 4. 2 to the 4 beta. Ji. So 2 to the 4 here. Beta what we can say P2 plus beta this is what 2000 beta you can take here 2 5 the 10 here. So this is what you can say basically 500. So this is what beta ji 2500. So P2 student P2 you will get 500 Pascal. P2 beta you will get 500. Okay. SR01. Okay. Okay. Advik. Okay. Any more candidate? Okay. Okay. Fine. Fine. Fine beta. Very good, yeah. But I'm very happy to see bacha everyone here for your interest in physics point. Very good, bacha party. I'm very happy to see here all of you, bacha. Okay, beta have look, beta the next question, my dear. Everyone, beta we have to do students next questions here. Beta IIT Advanced 1998. Students IIT Advanced here 1998. Everyone, bacha, do this question here. IIT Advanced bacha party 1998. Beta note down questions everyone. Water from a tap, students. Water from a tap, student. Water from a tap. Beta जी IIT बच्चा 1998 advance 1998 बच्चा. This is JEE advanced बच्चा party. Okay, so what's questions, my dear? Water from a tap. Water from a tap emerges emerges vertically emerges vertically downwards downwards with an initial speed with an initial speed of 1.0 meter per second. The cross-sectional area the cross-sectional area the cross-sectional area of tap is 10 to the power minus 4 meter. Assume assume that assume that the assume that the pressure is constant throughout throughout the stream throughout the stream of water and and that the that the flow and that the flow is steady. The cross-sectional area, the cross-sectional area of stream 0.15 meter below the tap edge. Water from a tap emerges vertically downwards with an initial speed 1.0 meter per second. The cross-sectional area of the tap is this. Assume that pressure is constant throughout this stream of water, that the flow is steady. The cross-sectional area of the stream is 1.15 meter below the tap edge. So beta options 5 into 10 to the power minus 4 meter square. Next student, 1.0 10 to the power minus 4 meter square. Option C beta 5.0 10 to the power minus beta 5 whole square. Last beta 2.0 10 to the power minus 5 meter square. Okay, okay, do everyone just try to just figure out what is the data mentioned in the question. According to data beta, you can move ahead. Student, according to data, you have to move ahead. Okay, I also think here this question is look like new. I don't know, student, without solving, I can't say because we have to find in terms of like we have to find beta the area for this question. How can the answer will be same only? What I found previous questions. Okay, but this is a different questions here. There is information mentioned like pressure, area. Okay, bacha, have look everyone here. The question, bacha party. How can we do? Listen me carefully. Student questions maybe answers same. I don't know, but my uh, student intention is just to just solve this question to tell some message here. I can say behalf of these questions. Hi, yes, I'm doing my dear. Yes, I'm doing my dear. Beta, be are pretty sure. Water from a tap. Water from a tap, beta, what? Emerges vertically, right? So, beta, let's make diagram first here. Diagram, beta, will help you to just understand these questions in a proper way. Beta, you can take there are two different, or you can say non-uniform cross-sectional views. Beta, you can take in consideration like this. So, beta, what's the water from a top emerges vertically downward. So, you can take beta water coming in this direction, right? So, this is V1. Then, Bachaji, what you can say, this is V2. This is V2. Now, students, you can take here, this is area of cross section, which is A1. This is what? A2. Now, students, just take here, consideration, height is H. Water from a tap beta emerges out in beta downward with initial velocity beta. V1 mentioned here. V1 bacha party, step 1, I'm just doing bacha. V1 is mentioned 1 meter per second. The cross-sectional area of tap means beta this can you can take bacha ji A1. This is 10 to the power minus 4 its meter square here. 10 to the power minus 4 meter square. Got it? Okay. Then let's assume that pressure is constant throughout. Means I can say pressure P1, P2 remains same. Beta, I can say P1 and P2, my dear, both are remain same. Yes, beta. Constant throughout the water that the fluid is steady. Cross-sectional area of tap. Okay. This H is mentioned here. Simple beta. We have found beta this one. H bacha how much? 0.15 meter. Bacha what you can say? 0.15 meter. Okay. So bacha ji from conservation of energy here, we can apply bacha party what? This is we because beta pressure remains constant bacha party. Okay. Uh, so now beta I can say bacha ji for this condition H bacha what beta we can use equations of motion third my dear. Student, you can use equations of motion third my dear, right? So this is beta. You can say V2 square, V1 square plus 2gh, V2 square beta plus V1 square plus beta. What we can say 2gh from energy conservation here. Okay, or beta you can use directly beta. You can call beta step. This is what step two. We can also use beta binary. I can say Bernoulli's equations. So beta here I'm going to use beta using concept of equation of continuity EOC bacha in short here. EOC student in short, right? So beta here you can what write bacha ji A1 V1 is equals to A2 V2. A1 V1 equals to A2 V2. Let us suppose you wanted to find what is V2. So V2 beta what you can say A1 A1 V1 by V2. So sorry A V2 beta yes this is you can say A1 by A2 into V2. A1 by A2 into beta, you can say V2. Got it now? Okay. But child, in this condition, you can feed beta in this equation. Let us say, you can tell my dear equations number one. So beta, what you can say bacha party over here? Beta, this is squared, means you can write beta this value feed beta in equations number one. So you can write this is A1 square, A2 square, V1 square, V1 square plus 2CH. Beta, V1 beta, just take this idea. V1 bacha party, you can take at this side. Or do one thing here. Beta, you can take LCM beta for entire. Then we'll get A2 directly from here. So bacha, what you can say, A1 squared, A1 squared, A2 is not given. Okay. Wait, you will get everything bacha. V1 squared upon beta A2, this is V1 squared plus 2Gs. Let us suppose I'm calling this is A2 square. So finally you can write beta A2 square is equals to A1 squared, V1 squared, V1 squared plus 2gh plus beta what we can say 2gs. So finally yeah, we'll get A2. Finally, bacha, you will get your value of A2 basically, right? So just do a square root bacha party both side. So A2 you can write A1 V1 entire root beta V1 squared plus 2cs. Everything further known for us here. A1 beta how much? 10 to the power minus 4. Beta take snapshot my dear this expression. Student take snapshot here. I wanted to change the page. Okay. Yes, my dear. So here you can write beta A2 is equals to beta A1 V1 V1 squared plus 2gs. A1 beta already 10 to the power beta minus 4 mentioned. V1 beta how much? 1. 1 beta ji root of beta V1 beta remains 1 plus 2 into beta G you can take 10 here. This is 0.15. Beta 0.15 beta mentioned here. Beta H. 0.15 बचा. This is beta what we can say? 1.5. 1.5 into 2 beta 3 only basically. So 3 plus 1 beta 4. Beta what you can say? 3 plus 1 4 yeah. 2 बचा body. So you can write over there बचा. A2 is equals to 10 to the power minus 4 by 2. So you can say बच्चा this is what 0.5 10 to the power minus 4 beta, or you can also write 5 into 10 to the power minus 5 beta. Any option is there बच्चा? Yes, 5 into which option beta? Okay. Yes, SR01 beta. Very good, my dear. Very good job. Option C beta correct answer for this question. Champa, correct. Yeah. Correct, my dear. Champa, correct, Mr. Bhadi. Okay. Bacha ji, have a look at next question. Beta ji, have a look next question, Bacha Bhadi. Okay, I have many questions, sir, but I'm just trying to connect those questions with in those questions you can do easily, right? So just everyone here note down the next question, Bacha Bhadi. Cylindrical tank. It's a good question here. Student, advanced question only here. Today's session we are doing. Uh, Anyone wanted to write solution here? Anyone? Anyone from all of you? Anyone from all of you to wanted to write solution, or already you have written? SR01 beta, nobody yet. Good boy. Huh. So beta, what question here? Oh, I raised. A cylindrical, a cylindrical. Okay, good beta. My dear Advik, a cylindrical tank of base area A, of base of base area beta. You can take capital A, has has a beta small hole, small hole of area beta is small a, area small a at the bottom, at time t is equals to 0. A tap starts supplying water. Tap starts supplying water, supplying water into into the tank. What's the data advertise 01? Tank at a constant rate. Yes, got it. It's a super standard question. Constant rate alpha meter square. It's a rate meter cube. Sorry, alpha meter cube per second. Find the maximum maximum level to which water can be filled can be filled in tank. Find the maximum level to which water can be filled in tank. Right. Okay. Student, anyone want to try these questions or I have to do? Uh, Currently, how many present in session here? Just write hi everyone or Hare Krishna, right everyone? Sir, want to try. Okay. Hmm. Okay. Yes, I'll be present. I'll be present. Just anyone present in session here? Hare Krishna. Okay, Hare Krishna beta. Hare Krishna Advik. Hare Krishna beta. SR01. Oh, two candidate only. Okay, two candidate only present. Me, I can say SR01 Advik. So, we remember Advik Bacha during distributing chocolates. Only those candidate eligible for chocolate, those are, I can say, available in live session since beginning to finishing, right? And to last. Okay, remaining no one I can say eligible. Tomorrow also take your notes, beta. Yes. So, bacha, have a look, everyone here. The questions. Jai Shri Ram, student. Okay. Have a look, beta. This question here. What question says? Okay, a cylindrical tank of a base area A has a small hole of area small a at the bottom. Okay, beta, you can take it. There is a, container. There is a container, right? Okay. So beta, there is a hole. There is a hole, right? Beta, you can take arrangement kind of arrangement like this. There is, means you can take. There is a tap. There is a tap, my dear. Okay. So water coming, I can say into the container from tap. That is what means in alpha meter cube per second. Alpha meter cube per second. Student, alpha meter cube per second. Okay, fine. So, bacha ji, here, let us suppose you can take for consideration some amount of, because water can fill in vertical direction only, which so here you can write, let us suppose this is by. This is what, my dear, you can take for y. Okay, if water is filled to a level by in beta, you can say sometime here the ejection velocity, right, beta? So initially, bacha, what is the ejection velocity? So beta, what you can write over here? This is velocity of ejection. Root of 2g is bacha. So you can write over here. This is 2 gy. This is nothing but you can say velocity of ejection. You can say beta g velocity of ejection. Right. Now, bacha, I can say for next further bacha party, ejection volume rate we have to find. So, bacha, you can write step one. Now, beta ji, step two, ejection volume. Beta ji, ejection volume. In today class here, I can see someone asked what is the volume. Beta, it's very simple here. Ejection volume means we are talking about volume rate. Beta, what? Volume rate, beta. So ejection volume rate of water, you can write, bacha. Ejection volume rate. Ejection volume rate of water, which is what, my dear? Simple, yeah. As I said in the classroom, beta. Now, sir, 01. Bacha, what you can say? This two, A1, B1. Bacha, what you can say? A1, V1, right? Okay. So, bacha, here you can write, bacha, A into V. So, A beta remains area, A beta, small area, A can, bacha, right? Because, bacha, what's mentioned question here? Cylindrical tank, base area. This is base area, you get A only. Beta, you can take, my dear, this base area is what? A, my dear. Base area, beta, A, my dear. This beta, small hole, bottom of the tank, that is what? Small a. Beta, base area, capital A, beta, small a. This is what, my dear? Small a. So, beta, ejection volume rate. A1, V1, beta, you can do what? A into V. Students, you can use A into V, beta. Student A, V already we found. So, A into beta, this is 2Z into Y. To Z into Y. Now it I can see the water level. The water level in tank will become constant when water supply. When it about water supply rate. Bacha ji, because this is you already found ejection of volume rate. And what is this is? This is entire terms is equals to what? Alpha. Because if water is coming into the container with speed alpha meter cube per second, so this is remains constant. And which is equals to what? You can say alpha. Which is equals to what? You can say alpha. So beta, this is, yeah, you can write is equals to what? Alpha. What should we wish to find? Student, we wish to find the maximum level to which water can be filled. Means you have to find what is the value of y. You have to find what is the value of y. Okay, so simple, bacha. Just do a square root, beta, both side. My dear, do a square root both side here. So what you can say, bacha? This is alpha square is equals to a square 2g into y. What, bacha ji? 2g into y. So what is the maximum value of y? What, beta, we can write? This is alpha square a square upon 2g. Y is equals to what, my dear? Alpha square a square upon bacha. This is what? 2g. So beta, this is the answer for the question. You can note down fast here. Everyone beta note down fast, student. Everyone beta fast note down these questions here. I hope all of you written. I hope bacha party all of you written. Okay. Very good beta. Advik, my dear. Beta, next question here. Beta ji, next question bacha ji. Oh, good. Good beta sir 01. Beta, note down question with you bacha party. A water clock, a water student, a water clock, a water clock used, water clock used in ancient, ANICNT, ancient Greek, ancient Greek is designed, designed as a closed vessel, closed vessel with a small orifice. What, my dear? With a small orifice, with a small orifice O. Student, with a small orifice O, right? The time is the time is determined. The time is determined according to the water level, according to the water level in vessel. What should what what should we what should be the shape? What should be the shape of vessel for the time scale time scale to be, very good question here, to be uniform? Find mathematical find mathematical equation find mathematical equation governing governing curve governing curve A O B. It's a subjective question, sir. Also, Bacha ji, literally, it's a very good question. Beta ji, it's literally a very good questions. Okay, now beta, I'm just giving you a data of the means diagram is mentioned in the question. Yes, beta ji. Diagram is I'm writing beta. SR01. I'm writing, my dear. Okay, fine. Now beta, you can take as a consideration. Mhm. Yes, beta ji. This is the diagram here. Yes, yes, beta ji. This is the diagram, bacha party. You can take, my dear. This is x-axis. This is y-axis, beta. Beta, this entire length you can take from here to here, 80 centimeter. Beta, 20 centimeter. Beta, this is 80 centimeter. This is, my dear, 20 centimeter. Right. Okay, I'll write here one more time here because maybe, but I'm just telling what this is 20 centimeter. Okay, beta, this is 80. This is what you can see 20 centimeter. Now, it's what you can see here. If water level is, beta, what's in the question? Water cloak. A water cloak is used in ancient Greek, is designed as a closed vessel is with small orifice O. Okay, so beta, this is orifice O. Beta, this is what you can say orifice O. Okay, fine. So bacha party, let just take in consideration the time is determined according to the water level. Yes, beta. According to the water level, right? So if water level is at a height, let us suppose by beta this is common office here. So beta this I'm going to here just divide this thing. Beta I'm going to just divide this thing beta in two part so that we can easily visualize the situation, right? So beta let's try to understand it the things. I'll do here here. Yes, beta I'll do here here. But the upper part this I'm going to here just divide from orifice point O. So beta just take in consideration this is what my dear orifice point O. Yes, beta. So this is orifice, na? Yes, beta. So this is let us suppose in consideration, beta. Let us you can say you have to move by. In fact, this is remains by only. So beta, you have just moved little by, and beta try to figure out this situation. Student try to figure out this situation. We have just beta move by, right? So beta water filled into the container. So what you can tell, sir, particle is coming in downward directions. So let us say this velocity is v. So what is outlet velocity of this, I can say, particular portion of container. So water coming beta from here only. So v you can what write, root of 2g by 2g is na beta, we remember every formula here. So S is what y bacha party. So you can see V1 velocity, which is equals to 2g into y. V1 is equals to beta, what you can say, root of 2g into y. Okay, fine. Bacha now, what's in the questions here? I can say, have a look at the question once. Water level is vessel. What should be the shape of vessels for the time scale? Okay, shape means beta, definitely they wanted to know what is the equation. What is the equation? Okay, better do one thing here. What? Better if orifice, better this is point O. This is point O. If orifice is what? You can say area. But I can take air. Better what? You can take A. So what's a part A? Better in this direction, what we are considering? X. Better this is X, my dear, and this is you can say Y. This is what you can say by. Beta, this is x. Beta, this is what you can say by. Right. So, beta, now I'm going to use here equation of continuity. Equation of continuity. Okay. So, beta, V1 you can't say is what is this? Beta, this outlet velocity you can say something like this is outlet velocity, which is what? Root of 2gy. Now, since I'm going to use equation of continuity. Student equation of continuity EOC beta z equation of continuity here. What is equation of continuity? A1 V1 is equals to A2 V2. A1 V1 is equals to beta A2 V2. So you can take for consideration here because this is x. This is x by 70. We wish to find beta V1 velocity. So you can take beta what is the velocity coming out. So this is beta g root of 2g by into beta area remains, you can say A1 only, versus beta area, V2 we wish to find here. Because this is along x-axis, bacha party. You can take R as a x only. So what is area of circle only? So this is what? Pi x square. Beta what you can say? Pi x square. Right. So beta here onwards here, we'll get everything. So beta just squaring both side beta. what we can say 2g by a1 square is equals to v2 square pi square x to the power 4. X to the power 4. Okay. So basically, beta, we wish to find what is the equation. What is the equation? So you can write here y is equals to beta g v2 square pi square x to the power 4 upon which party 2g. Upon beta, what we can say 2g. In fact, here a1 square here also, no? So you can write this is a1 square. So this is beta, I can say mathematical expression here. They are asking to find the mathematical equation governing the curve AOB. Governing the curve AOB. Right. Right. If data everything is mentioned here in this question itself, beta ji, what is by bacha party? Can I take here? This is what? Remain entire length. Entire length is beta what? HE. So this is beta how much here? 40, 40 each. 40, 40 each bacha party. So we can write bacha party. This is the, I can see equation here. They are asking. But they also asking what should be the shape of the vessel for the time scale. So bacha party for this condition, you can say bacha for a scale to be what? Uniform. So V1 remains constant. V1 remains constant bacha party. And this is what? Beta 20 centimeter here. So we can write bacha here I'll write y is equals to 40 centimeter x beta g 10 centimeter. Right. And V1 remains constant with the party. What you can say V1 remains constant. This is root 2 of g of y. Further with the party, you can just fit the entire values here, will get answer. So beta x is what? Just I'll solve here for you. Beta x, this is 40 by then beta g, x is mentioned here. A1 square beta. We can find if the that is the conditions here mentioned in the question or not. A1, yeah, this is finally beta, just fit the value entire. So beta 40 into beta what you can say pi beta g v2 square into beta x 10 to the power 4 upper beta 2g into beta what? This is a1 square into beta what you can say a1 square. Now it's just solve here. So what you will get? This is 40 pi square. I wrote pi square only. You can see this is pi square only. Oh, here. Yes. Correct. SR01. Correct, beta. Correct. Advi, correct, beta. Yes, beta. This is beta. Pi square only. So beta B2 square here. Beta 10 square. Beta this is what? 2G beta what we can say? A1 square bacha party. Right. So beta further we can solve here everything. Will it answer of this? A1 square bacha party. Right now. So solve beta. We'll get here by also because this entire terms is known for us. So further solution here. So it's a literally good question with party A1 B1. Maybe it's tough for you beta this question I can say right. So I'm giving you a little easy question. Yes, little easy question here. One question beta just I remember beta I can say SR01 Adivik. That is mentions in your model question here. Just say to me beta. Just tell me share your experience. Did you completed this question or not? So, because I'm writing diagram only here because time is very less. I have. Yes, beta. Have a look, everyone. Beta, I can say there is what? I can say three liquids in a triangular tube. Beta, if you have done, beta, then just reply me. I'll not do this question. Three liquids in a triangular tube. Beta, anyone from all of you which those present in live session? Beta, this is your, I can say, beta, textbook questions here. Do you aware about this question? Beta, do you aware about this question here? Beta, there are three liquids basically, bacha, right? I'll use three different color paint. Beta A, B, C, bacha. There are three liquids here. Let us suppose this is green from here to here. This is just tell me the answer yes or no. Did you solve this question or not? Beta for B, beta this is the blue liquid. Okay, Advik, then I'll do beta. Yes, beta, I'll do this question here. It's again beta good questions here. Beta, in fact, I can see beta this is beta questions from statics only. Okay, do beta this question tomorrow. Beta, I'll ask this question in classroom here. So try to listen these questions carefully. I'll not see beta diagram. I can see entire statement here. If required, then I'll tell you slowly. So beta, there is another I can say liquid which is from here. This is there are you can easily recognize I colored I drawn in three different liquids. So beta, there are three liquids. You can say this is green color. It's different density, different density. This is different density. Beta, what's the question here? Just listen me carefully, both of you. A closed tube is in the form of an equilateral triangle. What mentioned बच्चा पापी? An equilateral triangle. So, beta, what's the angle here? This is student 60 degree. Beta is 60 degree. Beta is 60 degree. This is the mentioned बच्चा party. Okay, a closed tube is uniform tube beta, triangular beta, sides L. Beta, entire sides. What beta? Sides beta L is mentioned here, which contains equal volumes of three liquids, which does not mix. Makes sense here, correct only. And liquid density bacha mention what? 1 is to 2 is to 3. Beta I can take row 1 is to row 2 is to row 3 is equals to 1 is to 2 is to 3. Beta ji 1 is to 2 is to 3. Right. Then beta I can say if the tube is kept in vertical plane as shown in the figure, find the distance x in figure. Okay. In fact, beta distance also mentioned here x. Yes. X beta mentioned my dear. Student X also mentioned beta ji everywhere. Yes, this is X beta ji. We can take students from here to here. Beta from here to here. This is my dear remains X only. Okay. Beta for this condition beta from here to here. My dear again mention this is X. Oh, Divya beta fluid dynamics here. Divya beta it's a fluid dynamics here. Only beta advanced questions I'm solving my dear. Okay. So, bacha, we have to find basically x, bacha, party. Beta, what we have to find? Find the distance x in the figure. Simple, bacha. Density, this you mention 1 is to 2 is to 3. Find, find distance, find distance x, find distance x in the figure. Simple, beta, ji. Okay, fine. So, beta, for this question, to find x, here we write what? Pascal pressure equations. Because no, but everyone, you remember what is the statement of Pascal's law? If once you will apply pressure anywhere on the surface of container, so what you can tell? Pressure equally distributed everywhere on the surface of container bachcha body. So beta, we have to use the principle of Pascal's law to get answer of these questions. So, what bacha, let us suppose I'm going to just apply Pascal's law from point A. What, my dear? From point A. So, this is a bit of higher bit of pressure. So, using concept of now, beta, I can say this is the solution part of this question. Using student using concept of using concept of beta Pascal's pressure equation, using beta concept of Pascal pressure equation, right, my dear? Okay. So beta here, higher pressure, I'm just telling beta PA. Now here, this is X. So what we can take? X cos 60, X sin 60, X cos beta, X is sin here. So the charge density is what beta we can say? Let us suppose this is 3, this is 2, this is 1. This is 3, this is 2, this is 1 bacha party. Something changes there, so beta I'll take different thing bacha. So initially beta this is the P minus bacha party minus bacha what? X sine 60 degree beta. This is 3 rho into G. Beta this is what you can see. I have written pressure at A. This is what my dear pressure at A. So now beta I'm going to write here pressure at B. Beta what? I can say pressure at B. So beta this is rho bacha party. So here I'll write here pressure in two fashion. Here as student I'll write pressure beta in two fashion. So this is beta what I have written beta. This is what pressure at A. This is what my dear pressure at point A. Right. Beta the minus here. This is I have taken X. So beta what we can see this is X there. So remaining terms beta let us suppose because entire length is L. So beta how much this? This is how much here you can say. This is L minus X. So this is remains X beta. So student here I'll write L minus X beta. Component remains sin 60 cos 60 bacha. So I'll take sine here for height. So this is rho g is beta. Pressure simple here. Pressure due to liquid. What we can say? Rho g is my dear. All of you remember pressure due to liquid. What you can say, my dear? Rho gh only. Okay. So L minus X student. This is sin 60 beta cos and sin bacha party. L minus X equals sin 60 into beta g rho g into beta g rho g plus plus beta g. Uh, we have I have beta taken this idea. Remaining this side also responsible to generate pressure. So beta this is what you can say rho g x sin 60 degree. Rho g x beta g what you can say sin 60 degree. Okay, so this is I have written pressure at what? B1. Pressure beta what you can see here? Beta you can see this is beta for more clarification. You can write beta G A1 point. Beta G this point you can take my dear. This is B1. This point beta G you can take as a C1. I hope easily you can understand. This is beta I have written here. Pressure at A. This is beta pressure at B1. Pressure at student, good evening. Pressure at beta G P1, right? This is what my dear? This is what my dear? This is pressure at beta G. What you can say? B1. Because beta, this is X and beta. So this is what? L minus X. This is X beta. So at B1 due to two cause. Beta this length as well as beta this length here. So pressure at B1. Beta, this expression also beta I wrote, I have written for beta, you can say pressure at B1 beta ji. Pressure at B1, my dear. Okay. Now beta, this is I wanted to write this is the last expression bacha party for I can say this is what my dear C1. Okay. Okay. Okay, beta. I'll be clear. Now, beta, I wanted to write beta pressure at C students, right? So beta for C, what can I write? Beta remains, just we continue from here only. Plus, this is L minus X into bacha sine 60 degree. This is 2 rho Z is equals to pressure at C. Is equals to pressure at C. I'll write here once more. I'll write beta one more here. These all points. So beta this is student again I'm writing here. Pressure just same thing beta I'll write in one line. Pressure at C minus beta G X student sine 60 degree 3 rho G minus beta L minus X sine 60 degree rho G plus rho Gx sine 60 degree plus student. This is L minus X sine 60 here. So this is root 3 by 2 2 rho G is equals to PC. Is equals to beta G PC. So now beta I'll do one thing. Yes beta G. This is beta PC. Beta this is the PC beta and this is the pressure A. Beta both are I can say on same level. So this is remains same beta. This A and this C beta both are on same level. So my dear, you can say pressure at A and C cancel each other. Pressure A and C student cancel each other. Pressure students A and C beta ji cancel each other. Pressure beta ji you can say beta ji pressure at beta ji A and C cancel because both are lying on a horizontal plane on same level beta. I hope you know everything here how this is cancel each other. So now beta sine 60 what we can say root 3. So bacha this is root 3 by 2 into beta 3 density beta this is 3 row itself. So everywhere beta just do one thing my dear. You can see sir this row G row G row G row G finish. Right beta? Okay. Now bacha this is what beta sine 60 what you can write? Tell me sine 60 beta what you can write? This is what root 3 by 2. So x into beta root 3 by 2 into 3 then बचा party minus L plus x plus x beta जी and this is beta sine 60 here. So you can write beta this is what remains root 3 by 2 plus beta you can say x into beta root 3 by 2 beta जी this is what plus L minus x my dear root 3 by 2 into 2 which is equals to 0 beta जी right. What Adi Gucha? Okay. Listen carefully, beta. I'll repeat here. Calculation simple here. Beta, these two finished. Just beta, open the bracket. I'm not getting Adi Gucha what you wanted to say. Divik, my dear, I am not able to understand what you want. Root 3 by 2. Correct only, na? Hmm. So this is Adi Gucha. Beta, this is 3 root 3 x by 2 beta g minus root 3 by 2l minus beta g root 3 by 2x open the bracket here plus x into 3 by 2 beta g plus you can say root 3l minus root 3x. Right. Okay. Sir, x is equals to 1 by 3. Beta, one second. I'll see, bacha. I can say this is root 3x. Beta, this is remain same. So 3 root 3 and this is 4 root 3x minus x root 3 by 2. So this is cancelled. This is, student, you can say this is cancelled. Okay. Beta, this will come this side. So root 3 can take common. Finally, what you can write with party? This is minus 3x minus 3x root 3 by 2 नहीं आ रही everywhere root 3 हाँ we can say root 3 cancel everywhere correct. So now beta I can say for this condition beta root 3 cancel everywhere बच्चा so this is beta I can say simple minus root 3 is बच्चा see ना यार beta what we can say beta minus root 3x there so beta this is root 3 cancel so the 3x only beta g minus L plus x plus 12 minus 2x is equals to 0. So you can see beta this x Phoenix 12 minus L beta. How much we can see? Plus L. Plus L na beta. So x is equals to, let's see carefully here. This is minus 2x. What I did. This is finished. X. So L x beta ji. X beta I'm getting here x is equals to L by 3. Yes. How many from all of you answer me? X L by 3. Okay. I can say SR01. Okay, Advik. Good. So literally Advik SR01 just convey me here. This question it didn't in class. I can say this question available in your module here. This question is available in your module here. Okay, no one also asked as a doubt of these questions. It's an advanced question, I can say, lecture, so that I discuss these all questions. So that bit I discuss these all questions here. Otherwise, it's bit I can say. Now, beta ji, I can say, beta ji, just move next year. Beta, this is, I can say, beta, today, this is last question, beta party for today class. This is beta ji, I can say, last question, beta ji, for today class. Okay, I don't know. Yes, do one more question, beta. Very good question, beta. Yes, literally, beta. Very good question. Yeah. Come, beta, buddy. This question, beta. SR01. Advik, beta, note down a statement with me. Yes, beta. Advik, beta, note down, beta, statement with me, beta. It's a beta highly required. Literally, yeah, I never write, but now I'm writing. It's a literally good questions. Beta, literally good questions. Beta, note down question with me. Figure shows a horizontal tube. Student, figure shows a horizontal tube AB AB of length AB of length L rotating rotating about rotating about a vertical rotating about a what